Just one? Come on, you know interferometers, right?
Sorry,
Laser interferometry, has anybody heard about this?
it's been a long time. I'm a little sorry.
Gareth, come on you guys, jeez. Okay. Katrina.
Wait a minute, are you going to cut that out? You're not
Okay,
saying what
okay,
it is?
never mind, all right. Laser interferometers. Okay, a laser is a yardstick because it is a section of the remember the electromagnetic spectrum, all the colors? If you take a knife and you slice through it, at that slice point, you have a designated wavelength, a very, very thin section. Okay, so let's say this right here is producing 523 nanometers. This is a very, very thin line out of the middle of a huge, huge wavelength. The red, of course, this is 635.
Is it different than a diffraction grating?
Two different things completely. Okay, now, an interferometer basically takes a laser beam, puts it into a beam splitter, which is, breaks the beam into two equal parts. Okay, usually they're polarized, one's A, one's minus, whatever, but they now go in two different directions. They're still the same wavelength. One interacts with something else. Now, if you want to measure, you basically, because we know that a wavelength is so long, it gives us a very, very specific unit of measure. So if you have a mirror and you shine one laser here, and then you shine another laser here, and then you move this mirror back, now we can send those beams and we can put them back into another beam splitter and combine them, and they'll create an interference pattern, just like the scalar waves do when they combine. Now with that interference pattern, we can detect how far this thing is away from this thing. So in other words, once we do a minute atomic movement or whatever, it's going to tell us what that movement is. So depending on the length of the wavelength and the size of the wavelength, that is going to give you a very precise measurement. So when we make semiconductors and computer hardware and what have you, the size of those chips is controlled by the wavelength that's exposing the master pattern, which is what is the semiconductor. It's a photolithographic process. When the Americans came up with computer chips, we were using a wavelength that was yay big. The Japanese came along and said, oh, hey, what if we use a wavelength this big? We can make chips that are way smaller. Well, they did that, and that's when the Americans lost their lead in the computer industry.
We also use interferometry in astronomy to determine this astronomical distances of
Right.
objects.
It's the same thing. It's a measurement. Now, what they're doing here with scalar interferometry is that they can, if these have a certain wavelength, and this one has a certain wavelength, when those two wavelengths interconnect, one's going to interfere with the other and it's going to change it. So it's going to create a completely different waveform. Now, what if that waveform is destructive? Okay, well now, wherever those things meet together, that's where that destructive energy is going to take place. And let's say the same thing applies to mind control, weather control, what have you. Now let's talk about Katrina. Here we have a monstrous hurricane coming on the coast. Here's Florida, and here you can see Louisiana, and what have you. Now, notice the shape of this pattern, this area right here. Okay? That is a kind of a keystone shape, right? Notice the shape of this pattern right here. That is exactly the same pattern. Now, what's happening here? It looks almost like there's a pressure pushing down on the clouds. Now, remember how when they created the field, how it pushes the clouds all the way? What are they doing? Kind of looks like they're pressing the thing down. It's almost like they got a sponge and you're squeezing the water right out of it. Kind of, you know. So you think they're trying to make the hurricane worse here? You think they're trying to make the flooding worse, or you think they're trying to help? Is this the Americans doing this, or is this the Soviets? Who's doing this? But clearly, if you're familiar with scalar waves, it's pretty clear to see what's going on here. Chemtrails make scalar weapons test strikes visible. Okay. Chemtrails flow through these ionic skies to give watchers a very good idea of the intensity of which a strike was delivered. These strikes produce weeping cirrus streaks like the one seen above. The holes vary greatly in size from 0.5 kilometer to 100 kilometer or greater. Notice the converging waveforms. See the waves? We have two converging wave fronts. Now remember how I said it pushes away? Okay, so that means the source of this wave is over here. The source of this wave is over here. So we have converging waves, okay? At this convergence, we have an interference. Look at that big old hole. See that? Look at that contrail going right through it. Stops, starts back up again. That's pretty darn good aiming going on right there. Now, this is pretty important because what the heck is going on here? Why are they trying to learn how to blow big old huge holes in space that you can't even see? They say it's exhaust. We're supposed to believe that. Does that look like exhaust? These are motors, and this is where it's coming from. What's that? What does that do? You notice the Air Force markings? You know, I noticed that a lot of these chemtrails are coming out of areas like Vandenberg and what have you. You ever notice Point Mugu, Vandenberg? A lot of these high, and these are really high altitude. Not like normal aviation. Real high altitude stuff. This is not normal. I mean, come on. What does that? Okay, now, why? Come on. I mean, come on. You know? Look at this shape. How do you make a square cloud? Okay? Or how about this? A little bump here. If you see this, this is actually a corkscrew. How do you make a thing do a corkscrew? It's crazy. Anyway, bottom line, these things are so common that you must conclude that everybody in the countries where this is happening knows what's going on. They're letting it happen. American misuse of scalar weapons. What? The Russians the only ones who have this stuff? Come on. All right. HARP. Everybody familiar with HARP? Yeah. What is HARP for? Okay. I don't know what that means. High altitude.
Atmospheric research.
There you go. Thank you, JC. Have anyone ever heard of a woodpecker?
Research project.
Went right past me. Anybody heard of the woodpecker? Woodpecker? You would. Well, okay, the woodpecker came from Russia. Of course you would know about that. A good friend of mine, a guy named Dr. Bob Beck, not really a good friend, but he's, if anybody read the stuff from Mike Emery, you would have heard his thing. But anyway, he was sent to the Soviet Union to figure out what this woodpecker was. And what it was people in Portland, Oregon were complaining about these funny noises in their heads. Going tick, 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 tick. And the whole town, everybody was getting it. Nobody knew what it was. And what it was extra long frequency waves converging on this one point of the globe. Somebody was sending these things through the earth, and they were coming up and they were bothering these people in Oregon. Now, the official explanation that this is something to do with communicating with submarines. And we do the same thing. We use extra long frequency for communicating with submarines. But in reality, what the woodpecker was very similar to what we do with the contrails. They were setting up an electronic grid that they could use for aiming and calibrating their scalar weapon systems. Now, here's a picture from 9/11. This is the top of the trade tower. Remember the big towers on top of the trade tower? Okay? Well, somebody just happened to take this video. Now, the tower is going down. See a tower turning into dust here? Turning into dust. We should be reminded, yes, steel turning into dust. Okay? This is a steel tower. Look at what's happening here. Before this thing can fall over, it has turned into dust. See? It is now dust. How do you do that? Is that from fire? Did jet fuel make that thing? I don't think so. Something else going on here. These are cars in the general vicinity of 9/11. Now there's a ton of pictures like this. I could have had a whole half an hour, an hour and a half just on 9/11. So we're going to move really quick. But look what we have here. Look at this car. It's melted. But look, rubber tire intact. Okay? Look at this car. Melted. The steel is melted, and yet rubber tire intact. Look at this. Looks like something took a big bolt of lightning going across this thing, melted the car, fried it, broke the glass. Rubber's still intact. It was not flame. It was not explosion. It was not high heat. It was something else. It was something radioactive.
Kind of like that hijackers ID card magically
Yeah.
after the whole building.